Hi, Miss Weber's class. My name's Joel Speranza, and I heard you've been watching my videos to learn some algebra. And I got a tweet from you guys yesterday that said you were having some trouble with this really complicated bug question and how you could use an algebraic equation to solve it. In particular, I want to give a shout out to Cameron and Connor. I heard you guys were really interested in doing this algebraically rather than using a table. So I'm going to run you through it, but it's actually pretty tough. There's a few moving parts here. Now, I did see a tweet from you guys, and it was Tino and Matt. And Tino and Matt they did a really good job on this. So I'm just going to do some of the work that Tino and Matt did up on my board here. So here's a little table that Tino and Matt came up. They actually did theirs this way, but I've done mine that way. Day 1, 2, 3, 4, and 5, and then spiders 17, 15, 14, 12, and 11. Now, Tino and Matt saw something special in this. They saw that spiders were decreasing by 2, and then decreasing by 1 there, and then decreasing by 2, and then decreasing by 1. So what they then did was keep going, expand this table out all the way until they got to a time when there were 0 spiders. Now there's another way to show this as well, which I'm going to do right now. So I'm going to use a little bit of technology to solve this question. Now you can also just use some graph paper. You don't have to use something like this. I'm using a program called Algebra. It's pretty neato. You can use it on the web. It's pretty cool. Okay, so what I'm going to do is type in all of the points that we know of for our thing. So point A, there was a point here that was on day 1, 17. Okay, and you can see it pops up there. Now on day 2, it was 2 and 15. On day 3, it was 3, 14. On day 4, it was 4 and 12, and on day 5, it was 5, 11. Okay, there's a real problem here. Let me show you when I do this. It's a jagged line. It's not a nice straight line. Algebra is going to kind of fall down at this point. Let's have a look at that. Okay, so you can see we have a slight problem there because our line isn't straight. It's got these jagged bits. Now, algebra is really awesome and it's really cool and it does lots of cool stuff. But one thing it doesn't really deal very well with is jagged bits. But as you saw there, actually, let me show you 2 tables from the one table here, and you can see that we can sort of get rid of the jagged edges. So now what I've done is a little bit of mathematical trickery. I've taken this table and I've turned it into 2 different tables. Day 1, day 3, and day 5. So every second day are going into my first table there. And day 2, day 4, and I know day 6 because I can see the pattern. Day 6 has gone into here. Now, what that allows us is to make straight lines. You guys might have already learnt some of the algebra required to turn this into what we call a linear equation. Okay, that's just an equation that describes a straight line. Now, if you haven't learned that, that's okay, because I'm going to cheat. I'm going to use technology to do it for me. Okay, so like I said, I'm going to cheat a little bit here. I'm going to do it by using GeoGebra to help me out. So I'm going to put in one of our points, A equals 117. Let's put that one in there. B equals 314. Put that one in there. C equals 511. Now, my graph's not showing it, but it will soon. There we go. Okay, and I'm just going to draw a line through those points. Oh. Okay, it's given me an algebraic equation here. 3x plus 2y equals 37. Okay, so it's come up with a linear equation for us. And it tells us that the linear equation is 3x plus 2y equals 37. Now, that's not quite what we want though, because the x and the y, what do x and y mean? Well, that's our x-axis and our y-axis. But when it comes to this one, our x-axis is actually d for days, and our y-axis is actually s for spiders. That's what we want. That's a piece of magic right there. Because that linear equation will let us figure out anything if we know something else. So the thing that you wanted to know was how long would it take before we had 0 spiders. So all we would need to do is substitute 0 for s. Substitute 0 for s into this equation. Now I'll try that now. Equals 37. Now 2 times 0 is 0, so it's going to vanish. We have 3d equals 37. 37. Now we're going to have to get rid of this 3, so we're going to have to divide both sides by 3. D equals, oh, that's horrible, 12.333 days. So according to my algebra, it tells me that at 12.333 days, we'll expect to have 0 spiders. But you guys have already done the maths. You know the answer is actually just 12, not 12.33333. Now that's because if you remember, we have a jagged line. And it looks like when it hits 0, it's not during this, it's not on this line, but it's actually on this line. So I've got a problem there. Okay, more work to be done. Alright, so there was a problem. That equation didn't work for us. So I'm going to have to use a different one. And I'm going to use our other points. So 215, E equals 412, F equals 6, 9, and then I'll draw a line through those points. And that equation, 3x plus 2y equals 36, that's going to be our equation. Okay, so as you guys saw there, 3x plus 2y equals 37 is the equation of this thing, but that made a mess. Because the line that's actually going to hit 0 first is that first bit there. So that wasn't 3x plus 2y equals 37. That was 3x plus 2y equals 36. So 3d plus 2s equals 36. So if 3d plus 2 times 0 equals 36, 3d equals 36, and 3d divided by 3 equals 36 over 3, which is equal to, 36 divided by 3 is 12. Whew. Guys, I can see why you had a lot of trouble with this piece of algebra. It is complicated stuff. Now, what I really want you to take away from today is that linear equations, algebraic equations, can be represented in 3 different ways. They can be represented as a table, and that's what you guys did a really good job of, and you came to an answer using our table. They can also be represented on a Cartesian plane. They can also be represented with an x and a y axis, drawing some dots and drawing a line through them. Now this was a complicated one because the line went like this. we had to sort of mess around a little bit to get two straight lines instead. So, three ways to look at them: tables, graphs, and then algebra. These three things are all one thing. They're all three different ways to look at exactly the same thing. Alright, catch you later guys. Thanks a lot for tweeting me. Really appreciate it. If you want to send me any photos, anything at all, feel free. It's good to hear from you. See ya.